Hi folks, I'm Geek here. Unfortunately, we had an audio problem and we didn't capture any audio until about the 10-minute and 54-second mark. Sorry for the inconvenience.
I should also point out that the International Space Station actually has an APRS digipeater on it, which I think they currently have active. They change things up occasionally up there. And one of my friends actually was sending email through that when he was stuck in traffic in Detroit to a friend of his in Seattle, and he said that when he asked his friend to check on the route that the email took, there were literally 2 hops from his radio to ISS, from ISS to the receiver's radio in Seattle. And the other thing that you see tons of on the network are weather stations. They're basically like kit-built things that you can connect to your radio, and they'll continuously give like temperature, wind speed, direction, barometric pressure, all that stuff. And they're very popular. The other thing is that when you set these up, the National Weather Service is actually monitoring all of these weather stations on the APRS network. So if you don't like the fact that your local meteorologist is getting the weather wrong, you can help them out a little bit. As far as the frequencies go, typically in North America, the main frequency is 144.390 megahertz, which is on the 2-meter band. In Europe, they've decided to use 144.800 megahertz. I think Australia also uses that as well. But if you go to Bob Berninga's APRS.org website, he has a complete, it's a map with all the frequencies listed by country. And then in South America, Africa, and Asia, each nation has decided on a different frequency. Like some of them are using the .39 and .8, but others are on completely different frequencies in 2 meters. It's also sometimes used on UHF bands like the 440 megahertz 70 centimeter band or the 900 megahertz 33 centimeter band. This is particularly the case if they're using, if it's a weather balloon project or satellite, because they can get very high gain antennas in smaller spaces at those higher band frequencies. And then finally, on the HF bands, 10.151 megahertz lower sideband on 30 meters is the APRS frequency on HF. And that's mainly used by mobile stations in very remote areas like ships in the middle of the ocean or people who are driving RVs or camping in very remote areas like the Yukon Territory or whatever, where they're not going to see any kind of local repeater or digipeater traffic. And it's usually customary to try to leave the 30 meters frequency free for people like that because bandwidth on it is very, very limited, which I'll get into in a moment. Applications of APRS, position reporting, as the name says. It's used a lot for amateur remote telemetry like the weather stations or balloon projects or search and rescue teams. The network also receives information from the nautical maritime AIS network. So if there is any ship or boat in the area that has an AIS beacon on it for the purposes of collision avoidance, you also see that, and it'll also tell you like the dimensions of the ship and its in terms of its length, its beam, and its draft, and also typically its next port of call and when it's expected to be in. A lot of people use it when they're traveling to notify their amateurs of the current frequency they're on, so that, if I'm driving along and I start seeing a packet on my radio, I'll see the guy's call sign, first of all, but I'll also see that he's monitoring, a certain frequency on 2 meters. So if I want to talk to him, I can tune my radio to that frequency, and we can get in touch. As I mentioned before, you can send text messages over the network pretty much exactly like a cell phone. The only difference is that whereas SMS has a 160 character limit, APRS I think has a 128 character limit. And there's a lot of other different ways that you can send the messages back and forth. You can also send email, and there's even a newer client called yet another APRS client that allows you to send email to the amateur WinLink network over APRS. So if you're out of range of a WinLink server, you can hop through a couple different digipeaters and then send your email that way. Finally, there's Mike-E, which reports the model of your radio. And because the Mike-E packets are short, they're also used frequently on the 30 meters HF because HF is a bit more unreliable, and If the packet is mangled in transit, it's not going to be received properly, so shorter is better. The network is also used for marking events like tornadoes and wildfires. I've seen out west, particularly in Arizona, the local amateurs who are working for on like the fire search teams, they will be marking the positions of wildfires, presumably for fire departments or the Bureau of Land Management or that sort of thing. And it's also used for location and current status of search and rescue teams in the field, so that they can, be beaconing out that, hey, we're stuck in the mud, or we're currently in the search, or we've just found the person we're looking for. And back at the Emergency Operations Center, they can look at a screen at a glance and know exactly the status of everybody. The APRS-IS network is Internet Services Network. It's the Internet side of the network. There's at least several dozen servers, usually with the domain name, they use the host name APRS-2, operating around the world. I know I've seen my client connect to servers in Europe, in Ukraine, one time in China. I guess my app just decides to pick whichever server seems to be the least loaded at the time. But there's also several dozens spread coast to coast in the US. Each server will provide a full feed of all of the data that it's receiving on TCP port 10,152. People have noted that if you actually just connect directly to that TCP port, sometimes it does stuff like crash your internet connection, because while everybody's sending into the network at 1200 baud, when you suddenly ask, I want to see all the packets worldwide, which is essentially what you're doing there, that's a lot of data. Most servers also support an HTML status port on 14,501, which will tell you what other APRS services the server offers. And all servers use TCP port 14,580 as a user-defined filter port. So initially, if you connect to that, you'll get nothing. And as you open up more and more of your filters, you'll see more and more traffic. And a lot of the applications use this to show you basically limited parts of the network so that you're not doing things like crashing your cell phone's data connection or your radio's connection or whatever. Now we get into the apps. First of all, there's APRS Droid. It's free. It's available for Android. And it's fully featured as a tracker. You can send text messages with it. It basically conforms to the spec. OpenAPRS is the iOS equivalent. Yet another APRS client, which is available for all major operating systems, Windows, Mac, and Linux, BSD, that sort of thing. That's the one that can forward email through, and it also supports all the other features. It can be a client, it can be a tracker, that sort of thing. And then there's the good old UI View 32, which is for Windows, and APRS Messenger, which is also for Windows. Most of the time, those aren't used much anymore, but because they have a lot of features they have flexibility as far as which digital data modes you can send in, that makes them more useful on the 30 meters HF band. One of the newer ones is called Direwolf, and it acts as a sound card software terminal node controller. It's fully featured, and it can act as a digipeater, an iGate, or a virtual TNC for other software packages like Zaster or UIView 32, or pretty much you name it. And I pronounce it Zaster. I've never heard how it's supposed to be pronounced. Xaster is the open source APRS client that's available for most Unix implementations. Since I'm not using my laptop, I can't really get out to the internet and show you APRS.fi, so this is the kind of a still of the demo. This is actually from when I landed at Baltimore Airport, BWI in, is it BWI or BM? Anyway, it's the Baltimore Airport. I was going to ShmooCon in 2014, and I fired up APRS Droid right as my aircraft touched the ground. And if you look, what I found very interesting, it's kind of faint here. This red car icon is labeled WB4APR-9. Bob Berninga, the guy who designed the whole network and built it all, was driving by Baltimore Airport right as my airplane touched down. That's his solar-powered Toyota Prius right there. So it's kind of like, what are the odds? I mean, I'm just some guy He's the guy who designed all this. And apparently he was out for a drive, or maybe going to work, I don't know. But you can kind of see these WX icons, those are weather stations, and if this was actually the APRS.FI website and not just a JPEG, when I mouse over it, it would tell me all the weather data that's being received, or that has been received at that weather station recently. Likewise, on these tracks, like, the most recent one is marked with the icon, and then previous ones are marked with little red dots. If you click on the red dot or the icon, it will also tell you the information that was in that beacon packet. So like on a tracker, it'll tell you probably the person's latitude and longitude, their altitude, their velocity, that sort of thing, and also any kind of, there's like a text comment field, so you can put in anything that you want. So like actually you can kind of see that here. On mine, I've actually, when I was taking the image, there's my call sign, and I've got SSID-7. There's the date, the time, my speed, the bearing that I'm traveling in, and I'm at sea level apparently. And then my comment is Shmoocon or bust, monitoring 146.5800 megahertz in simplex. So that if somebody saw that, they would know my radio is turned on, and they could contact me on that 2-meter frequency if they wanted to talk to me. So that's pretty much what we're going to have for the demo. The basics of hardware that you need to get all this going is an amateur radio, a GPS unit for position and time information, and a terminal node controller or other packet modem. Originally, back in the 80s, even in the 90s, each of these devices cost hundreds of dollars each. Many hams tried to homebrew their gear, and if you start looking for images of homebrew APRS trackers, it's a wilderness of all kinds of weirdness. People had put pieces of plywood on the dashboard of their cars and screwed down the radio and screwed down the GPS and, routed cables in odd ways. People, sometimes it's a jumbled mass of devices in an old military surplus pouch. A lot of this stuff winds up being very temperamental because of how people put it together. And for a long time, many people weren't using the network because it was difficult to get on until the commercial companies started getting into making the hardware business. In the last decade, particularly Kenwood and Yaesu, but I think there's a few other amateur radio hardware companies that are now getting into the act. But they're now building radios that have all of the APRS hardware on board, and GPS unit, the TNC, your packet modem, everything is all built into an HT or a mobile radio. The first gen units were like the Kenwood THD7A and the Kenwood D700 mobile. And they're usable as it goes, but the second generation are greatly improved. However, all of, like the D72 and the D710 and the Yaesu VX8 series, but all of these still cost several $100s, and it depends on how crazy you are into ham radio. Like, I would buy this stuff when I have the money, but there's cheaper ways to go. KD8RTT, who at the time he made the video on YouTube, if you search for his call sign, you'll find it. He was, I believe, an electrical engineering major at Case University in Cleveland, and he decided to see how cheap he could go on making an APRS tracker. So he used a Baofeng UV5R Plus HT, which I've got it listed for $45. Sometimes you can find them for $30 on Amazon. A stereo audio patch cable to go from, well, we'll get into where that went in a minute. An old surplus Android phone. We all have a drawer full of those, right? And the APRS Droid app from Google Play, which if you sideload it, it's free. If you decide to support the developers, they ask for $4.95. And basically what he did was he used the patch cable to connect the 3.5 millimeter jack on the Android phone to the mic in jack on the HT. He also connected an external, I believe it was 5,000 milliamp hour USB battery to recharge the whole thing. And what winds up happening is this APRS Droid when it senses a change in position, it sends a packet out as audio into the radio, which is set as voice-operated transmit. So when it hears something on the mic jack, it just transmits it. And this is what the whole system kind of looked like. And basically, as an experiment, what he did was he boxed all this up, and I think shipped it UPS back to his parents' house in Indiana or Illinois, something like that. And the surprising thing was that it worked. And also, when I gave an earlier version of this talk, I think it was at DerbyCon a couple of years ago, somebody pointed out that shipping an electrical device that's powered on and a lithium-ion battery violates postal regulations, so don't do that. But what I found interesting was, and you see it in the video, he actually was able to see 4 packets from this, even though he had no control over the orientation of the antenna, no control over where in the UPS truck the package was shipped. Like, is it in the center and therefore really shielded, or did it happen to wind up, in the top right next to that nice fiberglass skylight? But basically, something this cheap and this random, when it got within maybe 300 meters of a digipeater or an iGate, was able to transmit packets and verify its position. You can also use Raspberry Pi, and there's more and more kits available for, I think they call them capes on the Raspberry Pi. I know on Arduino there are shields. Or you could just run Zaster or Yak or whatever you like, especially on the Raspberry Pi 3, because, what is it? Like, I think, aren't they over a gigahertz in terms of clock speed now? And the thing that I've been working on my Pi is I want to also run, something like a light SQL database where I can put all kinds of events in there for my hackerspace. And so, the digipeater at our hackerspace will then, on meeting nights, it'll, like 6 hours before the meeting, it'll start reminding people who have amateur radios, hey, we're going to have a public meeting, you might want to stop by. Or, there's a class coming up about this craft or how to use the lathe or whatever. And you could use that for anything you like. But I think that would add even more flexibility to a network where you could just basically be scheduling packets to tell people about things that are coming up rather than just what's happening right now. And the Pi could probably also be used as a WinLink email node, but WinLink is a little bit outside of what we're talking about. Basically, it's a global amateur radio email network that allows people to send SMTP email basically from anywhere. And it's sort of, the ARRL is sort of pushing it as the future of long-range text communications, and has been for about the last 10 years. For Arduino, which I mentioned before, there's a BirdOS, I guess it's called, project that is implementing APRS for the Arduino, and then there's several different shields that you can get, like the Trackduino. Adafruit makes their own APRS shield, as does Argent Data. Argent Data does a lot of different things with packet radio generally. They have a lot of products for APRS, but they also have a lot of products for commercial land mobile radio and things like that, and some of which you can actually modify, if you like, back into ham radio. And then there's also the EXT Digi software that's a software image for the Arduino that implements APRS tracker client. As far as open source software, the great granddaddy of them all, which apparently it's still in beta, it's like, latest version I found is 0.69, I think. It's not updated very frequently at all, but it converts your computer directly into a TNC using the sound card, audio cable, and mic cable connected to your radio. And a variant of this is used especially with HF APRS on 30 meters. And of course, Zaster is currently the state of the art. In order to get both of them to work, you need to compile in the AX.25 packet module into your kernel, and the APRS-D server daemon must be installed and running. We're going to start getting into HF, high frequency radio, and so I just briefly want to go over what I'm sort of talking about here. There's UHF, which is where most people want to do a lot of their work, and I'm saying even commercially, it's the hot band right now. It's 300 megahertz to 3 gigahertz in terms of frequency. Propagation is line of sight, but it's best for high bandwidth applications and for use in urban areas. All your cell phones operate in the UHF band. Wi-Fi at 2.4 gigahertz operates in the UHF band. HDTV is up here. The 440 megahertz ham band, the 900 megahertz ham band, the 1.2 gigahertz ham band. 2.4 gigahertz is also a ham band in addition to being Wi-Fi. All that stuff is UHF. And then VHF, which is 30 megahertz to 300 megahertz, is mostly line of sight. When you get into the very low VHF part of the VHF spectrum, like on the 6 meter band or down around 30 megahertz, occasionally these clouds of ionized gas that are ionized by sunlight and the ultraviolet light in the E layer of the ionosphere will refract VHF signals. So occasionally you'll get stuff where the band that you were expecting to only get a 50-mile range out of, all of a sudden you're getting a 500 or 1,500-mile range out of. But that's not predictable. You can't rely on it. It's low bandwidth most of the time. Like on the amateur, now part of this is actually FCC regulation, but on the amateur bands, we're typically looking at 1200 baud, 9600 baud, 19,200 baud. That's about the max. But part of that's due to a 1979 FCC rule that has limited the bandwidth on amateur bands, and we're currently working to overturn that. And then there's HF, which is 3 megahertz to 30 megahertz. It will refract off of the ionosphere at various layers, and depending on the band, the band you use in HF, you can get somewhere between 500 miles of range out to half the planet, 3/4 of the planet, depending on what you do. It's extremely low bandwidth, however. The maximum on the 10 meter band is 1200 baud, and on all the other bands, the maximum is about 300 baud. There's some hacks you can do to get it a little bit faster than that, but the problem is that you don't have a reliable, essentially your physical layer is not reliable. You can hear these flutters, or your signal will fade or suddenly get stronger. So, and it's basically because part of your physical layer is the ionosphere, which is, I sort of liken it to looking at the top of a very slowly simmering pot of water, that you see all these currents and eddies and turbulent upwellings and things like that, that are, if you're trying to refract a signal off of that or bounce it off of that, the angle that your signal is going to be coming back down is going to vary, so you're going to get weird multipath effects and all sorts of optical and radio effects that don't affect you at all in line of sight instances. So with that, we'll get into APRS in the 30 meter band. Like I said previously, on 30 meters, you typically have a 500 to 2,000 mile range. And under favorable conditions, that can expand to basically the size of a continent like North America or Europe or, Australia. I wouldn't really expect it to necessarily cover all of Africa and Asia from a single location. And because of the ionospheric effects I was talking about previously, you want to have your packet format to be as short as possible, which is why the Mike-E packet that was originally developed to just identify the model of radio that you're using, it's about 33% shorter than the standard APRS packet, so it's very favored on HF. The comment field that, like you saw in the example image where I was, just kind of blathering on about shmoo count or bust and what frequency I'm using, on HF I wouldn't be doing that. I would have something very, very short, maybe just my call sign. And in your packet software configuration, you don't want to include a path for the routing protocol because you really don't want to have it to digipede. Since there's only 300 baud of bandwidth available in the channel, and your signal is quieting an area possibly 2,000 miles in diameter. It's possible, basically you could be causing a lot of collisions if you start wanting to repeat a packet that's now effectively orbiting the planet as it gets repeated. You can use the typical AX.25 packet mode, but on HF, phase shift keying at 63 baud or multi-frequency shift keying at 16, which basically means you're still changing the tone of your signal 300 times a second, but you have 16 different tones, so each one of those tone changes can give you 2 bytes, which is a hack to get you effectively more bandwidth. And both of those were specifically designed for HF, so they're likely to work better than AX.25. And a lot of people, and this is part of the reason why UIView32 and APRS Messenger are still used, because they have native support for both of those data modes. And I've talked a little bit about this with the keeping your path blank on 30 meters. On 2 meters, or on UHF, you might want to put basically APRS has a distance vector routing protocol within it that uses these statements in the path as as the routing protocol. So wide22 tells the digipeater, digipede me up to 2 times, and then as it digipeats, it's going to reduce that, it's going to decrement that last 2 down to 1, and then the next digipeater or iGate is going to decrement it down to 0, and at that point it's not your packet is not digipeated anymore. If you're in remote areas, like for example the Upper Peninsula of Michigan or rural Canada, you might want to use wide33 to get back to an iGate, but like in a place like Philadelphia, that's going to result in a lot of people seeing a lot of packets that they're going to think are unnecessary when, 500 miles away in Washington, D.C. on 2 meters, they're seeing your car in Philadelphia. This tends to annoy people. And then, like I said, on 30 meters, don't put anything there because you basically just want it to be received, and mostly it's iGates on 30 meters anyway. So you want your packet to be received and transferred to the internet as quickly as possible. As for future directions, and some of this has already been done, I'm starting to see people who are using RTL SDRs as iGates, but there's a lot that could be done with the HackRF or other SDRs that are bidirectional. You could basically configure that SDR as whatever you like, an iGate, a digipeater. I'm interested in possibly seeing what you could do with frequency hopping spread spectrum, similar to the Navy's enhanced position location reporting system, which it's possible Berninga also worked on that, but because he also does research for the Navy. Or, digipeating on multiple frequencies, like transferring traffic from the 2 meter band to the 440 band for keeping the 2 meter band uncongested. But that's all in the future. Then that's it for me. Are there any questions? Yes.
So you would run a gateway that allows message relaying between APRS and DMR radio to kind of have it built-in text messaging?
I'm honestly not sure. I haven't seen that. I mean, I know the DMR repeaters are showing up on APRS as a lot of them advertise their presence on APRS. But I'm not sure that there's it would be a great idea to link those two systems together. But I haven't personally seen it yet. Any other questions? Okay. Thank you.